Bulk handling was our first truly autonomous control system. And what you see here is basically in the port of Hamburg, that's Hansaport. You see a grab ship unloader, a big bulker, iron ore and coal. And when we were starting automation in this market, we were first looking what can the human do. And this defined our requirements because these machines were all already existing. They were just operated manually. So we were looking at accuracy requirements of about 10 centimeters to position a big stacker reclaimer into a stockpile, up to about 0.5 meter, which is what a grab ship unloader needs when we position a grab into a vessel. We also looked timing-wise at something between 20 seconds, that's basically how fast can a moored vessel move into a stockyard, up to 2 minutes, where we have a stacker reclaimer that basically has to react to changing stockpiles, landslides, weather, everything around. And range requirements that were between 10 meters for a train loader and about 150 meters for a stacker reclaimer. So the main reason why this wasn't done earlier, why it wasn't done before 2000, is not because iSAM didn't exist then. The main reason is that sensor technology had only matured in 2000 to a point where you could automate these big machines. And we will see later in the presentation that the same applies to container automation. Automating any big equipment means we have to answer 2 questions. One question is, where is the machine? And doing this in a big stockyard is quite challenging. In the end, it's easier to measure the distance to a couple of satellites traveling the space at 10 kilometers a second versus building long distance measurements along a 2 kilometer long stockyard. So the introduction of RTK GPS, courtesy of the American taxpayer, was the first solution to get centimeter level accuracy to a big stockyard. At the same time, 3D LiDAR became a real opportunity for vision systems. Computers are not as intelligent as humans are. Computers need additional 3D information to be able to understand their environment and properly position a grab into a vessel or a stacker reclaimer into a stockpile. I know, by the way, that there is a famous guy called Elon Musk who sees this differently. He says you can do this with camera alone. And I think he was right in many aspects, but he isn't in that case. You really need 3D LiDAR to fully automate large machinery in industrial environment. That's the technical side. We were lucky enough to have one port here in the port of Hamburg, that's Hansaport, which was willing to give the technology a full rollout. We were starting with train loaders in 2001 and 2002, mainly because train loaders are relatively low-hanging fruit. They are easy to automate. They only move on the rail. You have a locomotive in front, which we call a robot here, and we have a straightforward process. So that was the first machine that we did. In parallel, we tackled the stockyards. Stockyard, again, is a controlled environment. It's owned by us, or it's owned by the port of Hamburg, and we can control access to it. And the stockpiles are changing by nature, like landslides, rain, but they don't change that quickly. So the stockyard was the next one, and it also produces a big economic benefit because stockyard machines are needed both when you unload ships and put the material on the piles, and when you finally transship it to rail or barges. The next big step were ship unloaders. Ship unloaders happened between 2009 and 2012, and that was the first time that we crossed the automation barrier to the water side, basically operating a fully autonomous machine on equipment which is not owned by us, it's owned by the shipping company. And that was really a major challenge to get automation out of the controlled environment and bring it into the ship. After having done the ship unloaders, the ship loaders were relatively easy. It's again, vessels owned by somebody else, but we have proven already with the ship unloaders that we can do it, and ship loading is a relatively slow process. The commercial impact of this was that when we started in 2001, or we started in 1999, Hansaport needed 120 employees to handle 8 million tons per annum in bulk handling. Today, 112 employees are able to handle 15 million tons per annum. That's roughly a doubling in productivity that is coming by removing operators from the equipment, bringing them into control rooms, reducing idle time, and giving this personnel the opportunity to control more than one machine at once. After we have done the development in Hamburg, now comes a part that is not so interesting for the terminal operator, but for iSAM. We moved to a global rollout, and today we have more than 60 fully autonomous band handling machines running worldwide. We currently are building 12 more autonomous stacker reclaimers in Australia, 4 grab ship unloaders in Canada and Japan, and 8 ship loaders in Australia. So this is really an international, interesting business. 3 of the 4 leading mining companies globally use our technology. That's BHP, Rio Tinto, and Vale. After having shown you a lot of slides, I want to show you how it looks in real life. And what you see here is an area that we call back reach. That's the area behind a grab unloader where you can temporarily store material before you take it back with a grab unloader and either send it to a train or you put it on the main stockyard. And we have used that area to develop the technology because obviously I can't start running a fully autonomous grab unloader into a ship and then suddenly notice that my control isn't as good and I damage it. So we use that area to basically develop movements and to bring it to a point where the system can handle a grab as good as a skilled operator can. And what you see here, obviously it's not the first grabs that we have taken, but what you see here is how we tested it on a land site, and it's still used to offload material from there. What the computer sees is entirely different, and it's also not. Basically, what we needed to do, we needed to give the computers a know-how where the stockpile is, which you can see below, but we also had to teach the computer how it can handle a grab like a skilled operator can do. And what we do here is we have active sway. We have the trolley up there, that's a green dot, and the laser scanner is more or less running down the holding and closing lines until it is finally finding the grab. And obviously the grab has to be at the end of the holding and closing line. And with this knowledge, we get an update 10 times a second where our grab is in terms of sway. And we can really throw it into corners like only very skilled operators can do. This looks easy, but it isn't. Those of you who have ever trying to run a crane will see that sway dampening is already difficult, but to make active use of sway is even more difficult. That was on the land side. This is how it looks in a vessel. You will recognize the typical Hamburg weather. We can take a grab into a coal ship, and we have a corner there, and about 50% of the material is under the deck, so it can't be reached straight from the top. So again, what you have now seen on the land side, we do in a vessel, we precisely drop a grab in a corner with about ½ meter of precision without hitting the ship, but still being able to clean it out like a skilled operator can. By the way, speaking about skilled operators, one of the biggest benefits of automation is that you gain consistency. When you do this manual, you find operators who can do 2,000 tons per hour, and others will only manage 1,000 tons per hour in the same situation. The automation, on average, will maybe do 1,800 tons, but it will do so consistently, making logistics planning in the port much easier. So the last video is a bit for bragging rights. I did that myself on a ship, and I had a first officer from India standing next to me, at this point asking me exactly what I was doing, and that I would have to pay his ship if I damage it. And you see here with which precision we are able to bring a big grab that, by the way, weighs about 25 tons into the corner of a vessel and take out material.